Well, good morning, everybody. I hope we have an audience out there at this point. Katie, can you give me a thumbs up if we're live? And
yes, we have 54 folks pre-registered, and we're in the 30s now. So people are
cool.
Joining us. Yeah, this is great.
Very good, and welcome on an early and finally sunny morning. Makes it a lot easier for me to be up and around at this time of day. First, I'd like to introduce myself. I'm Doug Snyder. I'm the Executive Director at the Mississippi Watershed Management Organization, and I have been attending and or part of these councils meetings for probably 20 some years at this point. Today's Energy and Environment and Transportation Research Council webinar is going to feature a couple of good speakers, and that's evidenced by the number of people we have attending. So again, welcome. I'd also like to remind everybody that we are recording this today, and we will post that video recording to the event page so that anyone can view it after today's event. We'll also be posting the slides that are used during the presentations. At this point, I'd like to invite Katie, our co-chair, to introduce herself. And there we go. Hi, Katie.
Yeah, hi, I'm Katie Kowalczyk, and I am the vice chair for this council. And I work for the city of Minneapolis as a water resources coordinator. I came in as the green infrastructure coordinator. So that's my background, specifically around transportation and environment, around water resources.
Great. Thanks, Katie. The CTS Councils is a forum for transportation professionals and researchers to exchange information on current transportation issues and trends. It brings together university staff, faculty, practitioners from public and private sectors, and recommend direction to participate in improving the center's research, education, engagement programs. Katie, is our link on up here somewhere that we can get to? Or do we come to that next? Maybe we'll
post that in just a moment. Thank you for reminding me. So in the chat, I posted the link to the CTS Research Councils if folks are interested in learning more about them.
Great, I can highly recommend that. It's been a very good experience from my part on it. It's a terrific way to network with other folks that are across many disciplines that have common interest around transportation, natural resources, energy, and those types of issues. And back to the agenda for today. So today we're going to have a couple of presentations on how transportation can help reduce Minnesota's carbon footprint. Following those presentations, we'll have a chance at questions and answers. And then if we have time, hopefully we'll have time for a round robin sharing from all of the attendees at this webinar. At this point, I'd like to turn it over to Gina Boss, Associate Director at CTS, who can share a few housekeeping items with the group.
Well, good morning, everybody. And as Doug said, I'm an Associate Director for Engagement and Education at the Center for Transportation Studies. And on behalf of CTS, welcome you to today's webinar. Just a few housekeeping items that we wanted to mention. For questions that you have for the two presenters, you can feel free to use the Q&A feature, as well as if you prefer just to type in chat, you can certainly do that as well. And Katie will be monitoring those questions and will address those to the speakers following the presentations. Similar then during the round robin, if you have something you'd like to share, just type into chat, I'd like to share, and we will unmute you so that you can verbally give your update. For any students that are on the webinar today, if you could please send a chat message to the panelists so that we can monitor and keep track of how many students are attending. So you send it to all panelists so we know how many students are on the webinar today. And then finally, both of the webinar today is eligible for PDH and AICP continuing maintenance credits for engineers and planners. So send again a chat to all panelists, and Katie Kirk will send an email with the form to you so that you have a record of having attended the webinar. So with that, I will turn things back to Doug.
Thank you, Gina. There we go. So just want to remind everybody that every fall CTS has a research council, or a research conference. This year it's going to be held virtually on November 5th. It's a full day conference. The registration deadline is this Friday. Hope that you can attend. It's well worth the money and the time, I think. That's again another event that will cover a number of different areas and topics, and would send everybody to the webpage to get a look at what that conference schedule looks like, so that you have a better understanding of what's being presented at that time. This webinar today is the fourth and final of the webinar series that's been put on this fall. You can go to CTS's Research Council website and find recording of the previous ones. And as I said earlier, for this one, after we're done with it. And Katie, how long does it take to get this up on, the recording up and on?
Yeah, we'll have this recording posted within a couple of days, the recording and also the PowerPoint slides.
Very good, thank you. Next, I'd like to take some time here to introduce the presentations and speakers that we'll have today, both of which are focused on a couple of different methods to reduce transportation-related greenhouse gas emissions in Minnesota. The first presentation will highlight the University of Minnesota on intelligent energy management systems for commercial electric trucks. These trucks have potential to significantly reduce Minnesota's carbon emissions footprint due to their high daily mileage and energy use. Intelligent energy management is necessary to allow commercial fleets to electrify without significantly impacting range requirements, and for adding range certainty during winter months. The presentation will discuss how telematics data and two-way communication with fleet vehicles can be effectively used to enable electrification of that transportation sector. The second presentation will review the Minnesota Department of Transportation's Pathways to Decarbonizing Transportation in Minnesota project. The project began a conversation about moving Minnesota toward a low carbon transportation future. The presentation will include a brief overview of the key pathway components, modeling, public input, and proposed actions and recommendations. It will also include an update on the implementation of proposed actions and recommendations, like the new Mndot Sustainable Transportation Advisory Committee. A little bit about our two presenters, and then we'll move on to Will. So our first presenter will be Will Northrup. He's an associate professor in mechanical engineering at the University of Minnesota and the director of the Thomas Murphy Engine Research Laboratory. He received MS and PhD degrees in mechanical engineering from the University of Michigan in 2003 and 2009 respectively, and BS in mechanical engineering from Carnegie Mellon University in 1997. Will is a CTS scholar and principal investigator on many Minnesota and federal projects in the areas of energy and emissions from vehicles. His recent work has focused on energy management of electrified commercial vehicles using data science and machine learning methods. Our second speaker, Series Simmons is Principal Sustainability Planner at the Minnesota Department of Transportation's Office of Sustainability and Public Health. She leads coordination of sustainability planning and implementation to meet fleet fuel use, energy, water, waste, and other sustainability targets for Mndot's operations. Siri also provides support on agency efforts to reduce carbon pollution from the transportation sector in Minnesota. She received her master's degree in urban and regional planning from the Humphrey School of Public Affairs and her undergraduate degree in environmental sciences, policy, and management from the University of Minnesota. And I think we're on time. So I will at this point turn it over to Will to get his presentation up and started, and then we will begin.
Okay. Thank you so much, Doug, for that introduction. Hopefully give me a thumbs up if you can see the slides. You see them? Okay, we're good. All right, fantastic. Really, thank you for that introduction. And I'm happy to be here to talk to the CTS Transportation, Environment, Energy, and Transportation Research Council and present a little bit about the work that we're doing in connected commercial vehicles and specifically how that can enable electrification in that sector. It's a very long title. I'm sorry for that. The talk may be a little slightly technical, but I hope that this diverse audience can sort of follow along with my motivation and how we get to the research that we're doing and what kind of impact that it has for Minnesota and for the country in general. Okay, I can advance my slide. Okay, so first, I think I'm gonna just give some really broad perspective about CO2 emissions and greenhouse gas emissions from the transportation sector. As we know, and we've heard many times, probably a lot of you, that transportation sector accounts for about 28% of the overall CO2 emissions in this country. And those CO2 emissions come mainly from some portion from production of vehicles, but also from the combustion of fuels and the direct emissions of CO2 from that combustion process. Now, if we look on the right, we can see that the distribution of different greenhouse gas emissions from different source or different types of transportation, you can see that the medium and heavy duty trucks, which is the topic of my talk today, accounts for about 23% of the greenhouse gas emissions overall in the US. However, it's important to note that medium and heavy duty trucks like these account for only about 4% of the whole vehicle population. So they have essentially what I'm trying to point out is that they have an outsized proportion of the CO2 emissions and therefore are a really key target for reducing CO2 emissions from the transportation sector because they have per population have a very high impact. One thing that we also know is and have heard a lot is that electrification can lower net CO2 emissions. As director of the Thomas E. Murphy Engine Research Laboratory, I have to also pay some attention to overall how electric vehicles match up to electric vehicles and in the current state of technology. If you look at the life cycle overall CO2 emissions from including production and fuel and everything else that goes into the vehicles, you can see here that a number of these analyses have been done. And this one sort of is a typical analysis that you might see, showing the average sort of European car, what a hybrid looks like, the Toyota Prius, in terms of overall CO2 equivalent emissions grams per kilometer, and then what happens in the different countries depending on what the energy mix is. And you can see that what really is changing in those bars on the right is the orange line and the orange bar, and the orange bar essentially is how the electricity is made, right? So electrification has benefits. But really depends, the amount of benefit really depends on how you make the electricity. If you're like Norway and you make your electricity mostly from renewable sources, you have very little orange in that plot, whereas we have a pretty significant orange bar there, meaning that we get most of our energy from, our electrical energy from burning fossil fuels. So based on life cycle energy use, electrification is not a panacea. However, as you can see, it is a significant change, right? So it's a step change in reducing CO2 emissions and improving renewability. So therefore, I do think it's worthwhile to continue the research and to continue to try to get electric vehicles on the road. Okay, so now I'm going to kind of switch gears a little bit here and talk a little bit about how we can enable more electrification and how that and then in turns impacts renewability of the transportation sector. Is focusing on commercial trucks is what we've been doing mostly here in my group, and looking at telematics and data analysis as a way to do that. So although during COVID, commercial truck sales have been down significantly. In fact, I think medium duty truck sales are down some 30%, or about 20%, and heavy duty trucks like over the road Class 8 trucks are down like 30% in terms of sales in 2020. One thing that is growing is the use of telematics. Telematics is the communication of vehicle data through a network back to some server, which is then analyzed by the fleet or by the manufacturer to do certain things. And you can see here from this thing I clipped from Frost & Sullivan has a really nice report on the effect of telematics. It's a growing market, right? So 29.3 million vehicles in 2020. There's a 10% annual increase per year. So it's, even though vehicle sales are going down, the use of fleet telematics is increasing. It's an overall $17.1 billion market in the US. It's a huge market, and therefore, really indicates where a lot of the value is. And you can see there's a bunch of benefits, including reduction in fuel use. And if we think about reduction in fuel use for an engine-powered vehicle, that's essentially directly corresponding to CO2 emissions. So it's every carbon molecule you burn turns into CO2 ideally from an engine. So therefore, those fuel reduction in fuel expenses goes right to CO2 reduction for a given trip distance. You can also see reduction in total miles and vehicle utilization, idle time, all these things all play into fuel reduction and have environmental benefits. Okay, so we know telematics is important and it's growing. Now, how does telematics play in the part of the overall internet of everything, right? So the internet of things, the vehicle, the cloud, vehicle infrastructure, all these things. So telematics is just one piece of that, right? And so it's just one piece of how vehicles will be communicating in greater amounts in the future. So we're going to have vehicle communication to the cloud. We're going to have vehicle communication to each other, to infrastructure for traffic light timing, and all sorts of things are being researched right now and considered by planners and other people in municipal government and looking at planning of transportation systems. So obviously this is a big field. I want to take on one vision essentially in this talk and sort of in my research in general, and that is to think about this vehicle to cloud idea and thinking about how we might be able to collect more and diverse data sets. We can use the telematics data for sort of typical stuff like analysis for design feedback or predictive diagnostics. These are things that are being done right now. The third thing that you can use data for is in-use powertrain improvement. And this is not being done very much because it requires two-way telematics. So it requires that information is both sent from the vehicle back to some server to the cloud, and also from the cloud back to the vehicle after some data. There's also edge computing, which means processing these things on the edge of on the vehicle itself, and then sending information. For instance, we learned recently about Volvo's intelligent shifting technology, which is mostly an edge solution. It has a very powerful processor on board, and it calculates how shifting might be done over different grades. So what we're trying to do is a bunch of things. We're trying to develop these rule-based data approaches. So approaches that are not computationally intensive, approaches that don't require an excessive amount of data to be transferred back and forth to the vehicle, to improve fuel economy for plug-in hybrids. Even though plug-in hybrids are not being discussed very much, there's still some opportunity there with companies like XL Hybrid and others. Optimize on-route fast charging, predict EV range on route, and adjust shifting control to minimize energy use, such as the Volvo system I just discussed. So these are all things that we're considering and using data for, and developing algorithms that will help us improve the utility of electric vehicles and electrified vehicles, including hybrids, going into the future. Okay, so here's just a segue slide. So connectivity enables vehicle electrification. So we all know, well, maybe we don't if you don't drive an EV, but you know that range in EVs is limited, right? Because the battery size is, the battery is expensive, and even though battery power density is coming down, we know that batteries are a very expensive resource and they are heavy. So you have a limited range. You also have limited charging ability and extended charging time compared to refueling a conventional car. And the range itself depends heavily on things like ambient temperature. Because EVs are something like 85% or 90% efficient on the road, and engine powered vehicles are only like 25% efficient on the road, they have less waste heat to heat our cabin in the winter. So if you have an engine that's very inefficient, it can just use all that heat and heat your cabin, whereas an EV has to use the battery power and decrease its overall efficiency. So the vehicle also plays a huge role, especially for large vehicles, and driving behavior, of course, plays a role in all types of vehicles. In general, where heavy foot drivers generally have a negative impact on fuel economy, and we've seen that in data that we've collected. So what we can do is connectivity can provide range confidence. So we can actually use predictive algorithms to predict what the range will be. We can optimize charging, and we can do route planning and load distribution in terms of like payload and other things that you can do with vehicles in order to give fleets confidence to implement vehicles on their routes. Okay, what is the technology really that I'm going to be talking about? Well, really what it is a set of sort of places, right? So there's the cloud, where we store high time resolution data like vehicle speed and powertrain stuff that comes from on the vehicle, GPS location and exogenous parameters such like map and maybe weather information or road conditions. Powertrain recommendation, so we can do things like sending different modes, we can do different settings, we can actually send back information to the driver. We can do a bunch of stuff that we can send back to the vehicle, okay, in the cloud. So this is all stuff that you might do on a server somewhere. On the vehicle itself, you have in the middle, you can see there's a telematics, let me get my laser pointer out. So there's a telematics device here. There's some sort of DVI, driver vehicle interface. And of course the resource limited vehicle, which is your EV. That's going to require some real planning in order to figure out how it's going to make it through the route. So you have, and then of course on the infrastructure side, you've got what the depot is doing in terms of delivery routing or charging requirements that you might have, for the vehicle and how those might get implemented. So this is all kind of part of the technology that I'm talking about. Okay, so what are we doing and what projects are we doing, you might ask? Well, as Doug mentioned in the intro, I manage a number of different projects sponsored by both Minnesota and the federal government. We have currently the projects that sort of outlined in maroon there are the projects that are complete. And this is the kickoff project, which is one that I'll be talking a little bit about today in a couple of minutes, is our ARPA-E Next Car program, which was looking at connected delivery vehicles, like last mile delivery vehicles in the UPS fleet. We're also doing a really interesting project right now with Mndot that is looking at fuel consumption on snowplows. These are conventional, not EVs, conventional snowplows that we're using hotspot analysis and other analysis to look at how road conditions impact fuel economy on these vehicles and how we might be able to both manage snow conditions and as well as reduce the fuel use in these vehicles. So we also have a project, and the report is recently out, looking at hybrid fleet vehicles and how one might choose, or a fleet might choose, those vehicles for their municipal fleets. We've done some route optimization of plug-in hybrid vehicles, light duty, and we have 3 new projects here where we have doing electric management of Class 8 trucks, which I'll talk a little bit more about with Volvo. And then we have a brand new project that just kicked off this month, essentially looking at heavy duty EV implementation tool, and that's looking with PepsiCo and another telematics supplier. We're doing some DOE work with continuing on with the EV delivery truck range prediction for electric vehicles as well. Okay, so let's talk a little bit about this one, this cloud connected last mile delivery vehicles. And I'll spend a little bit of time on this one and just a little and less time on the other 2 that are just kicking off because we have less results from those projects. So you may have seen some of this if you've seen a couple of my talks before. You may have seen this before, and I apologize for that. But we've just completed this project as of 2020, and the aim of the project was to improve the fuel economy of these range extender equipped electric delivery vehicles through real-time powertrain optimization using V2C. And the goal really was to improve the energy efficiency by 20% of a baseline vehicle that looks like this. Okay. You've seen these, but this is a special one in that it's an EV with a little engine in it. The partners on this project included CTS, UPS, Workhorse. So we had a really nice project. Workhorse is a small truck manufacturer that makes these eGen vehicles. Okay. So what was our goal? So our goal was to introduce two interventions. Essentially, one was what we call connected energy management, and the other is the energy efficient routing, which I worked with Professor Shashi Shekhar's group and the University of Minnesota's computer science department on that particular aspect of the project. So what you can see is that, you know, what we really tried to do is from the baseline miles per gallon, what we call MPGE equivalent, we tried to increase the MPG by over 20%, and we really hope that was going to happen. So this was actually the project plan, and I'll show you what actually happened a little bit later and how we were able to implement it as planned. So the connected energy management is the first thing I'm going to talk about, which is minimize fuel consumption through practical rule-based algorithms, which is a computationally efficient way to do it. So sorry about the blurry truck. I didn't realize that the truck was going to be that blurry, but okay. You get the idea though. The truck is just an outline, and the powertrain is what I really want to emphasize here. So these trucks essentially have a battery. The battery is quite large and can power the vehicle most of the day without turning the engine on. And the engine is just used to, we call a range extender or REX. Engine is used to just charge the battery occasionally. Now, in order to get it through the route, if the battery starts to run low. Now, what this is, it's a 20 kilowatt BMW i3 REX engine. So it's very small. It doesn't actually power the vehicle. So you couldn't turn the engine on and like drive the vehicle down the road. It'd have to sit there and charge. So it has about a 60-mile all electric range, but most of the routes some of the routes are greater than 60 miles, which I'll show you. So UPS fleet has about 125 of these vehicles right now. It's unlikely they'll implement more, but they may, depending on how the full EVs that they're also implementing will be panning out. Okay, so the desired end route state of charge is 10%, and the driver sets the route distance. So the driver ahead of time puts in a number on the dash, which you can see here is programming it on the dashboard right here, and what the route distance is. However, they never do that because they're afraid that they're going to run out of battery. So they just set it to the highest value possible. And therein lies our problem. So the rule-based control for state of charge minimization essentially is that we mine data from these vehicles, from over 100 of them in various locations all over the country. One thing you notice just by looking at this is that all the vehicles are south. None of them are up here except for some that are in Columbus or near Cincinnati, which is where the vehicles are manufactured. So those are not actually in use. So really, if you think about it, the vehicles are only in the warm regions of the country, and that is mainly because the heating requirements in these vehicles is so unknown. And in fact, you don't see much EV implementation of commercial vehicles up here, which is a real opportunity, I think, for Minnesota, and something that I'd like to explore more. So the goal is that the vehicle returns to the depot every day with 10% battery state of charge, or SOC, to minimize the REX use. So essentially, we want to turn this into a complete EV. We do not want to run the REX engine at all, okay? And if we look at all the data, this is from 2017. And in this thing, you can see what the desired state of charge. Obviously, if it runs all electric, the state of charge when it comes back to the depot is going to be something along that green line. And then if it gets to the max range, which is about 55, I said 60, but really we want to see the desired SOC come back at 10%. And then so you see any of the vehicles that are above the line here, the green line, essentially are those that can be improved. So we've used the engine too much in these vehicles. They come back with too much battery power. So what we have to do is suck all these little dots down to the green line or below the green line. So that's the idea, right? So we want that's where the fuel savings can be achieved. Okay, So what we did is in this connected energy management thing, this is just an overview slide and some of the publications. Please, you can actually reach out to me. We have a ton of publications from this project, and developed a number of really nice methods that were developed by my student Pengyu Wang, and he actually received the Huber Award from CTS this last year. So yeah, so he was really productive and very we really got very far with this project. Essentially, we implemented this energy management strategy using machine learning. So I'm going to talk to you a little bit about the machine learning if I have time. How much time do I have? Oh, I'm running out of time, but I'll see what I can do. Okay. So essentially, the spoiler alert is that just because I wasn't sure I was going to get through it. So is that we improved the fuel economy by 20% on all these tested trips. And these are in real use. So by using this trained algorithm, we were able to pull those dots down to the green line using this algorithm. So how does it work? Well, okay, so here's the only equation that I'm going to show you. So the two rules are for the vehicle is the state of charge is lower than the state of charge reference line, which is this. So the baseline is here. The reference line is shown as the red line. So it's actually flat for a while because we don't want it to charge. So we don't want it to turn the REX on halfway through the trip. But then what happens is it starts to decrease. So this is what the state of charge looks like through the trip. Obviously it declines, and we want to make sure that it comes back with 10% state of charge. We want it to come down to the ideal value so that we use less fuel. And this is how we turn the engine on. So for the ideal condition, we turn the engine on fewer. So you see the fewer red bars than blue bars. And that's what we want. We don't want all this blue stuff here where the engine turns on a lot. We don't want that, right? Because that's wasting fuel when we don't need to. So how do we do it? What we use is what's called the reinforcement learning algorithm. So the idea is that in a reinforcement learning algorithm, the agent that has an agent, environment, state, reward, and action. This is kind of complex, and I'm not going to get too deep into it, but essentially the computer algorithm itself is the agent. The environment in our case is a model, a physics model of the vehicle that runs on all the previous trips. The state is available information from the current trip, and a reward that rewards fuel use but penalizes state of charge less than 10%. And the action is to change this variable L set, which is here, in order to affect when the engines comes on. Okay, so it's kind of like playing Atari. So if you have a deep reinforcement learning algorithm, so what happens is it takes some random action first. So what it does is it like plays, this is the environment, which is a breakout, and it takes actions randomly and learns which ones work. So this is the same thing we're going to do. So what happens is after a while, breakout, the algorithm learns how to play and can win. And in fact, this algorithm learned how to get to the top. Of course, if you ever play breakout, if you get to the top, then game is over because you just knock out all those bars. So essentially, it's the same idea. So in our case, it's the same thing for the UPS trucks. So we played the UPS trucks like breakout. Okay, so if I just go back and see if I can't get to I got to get to my slide here. Oh, here it is. Let me turn that off. Let's see, turn it off. Okay, yeah, so if I look at here, what happens is we take random action with this LSET value, just like you do when you play breakout, right? So it's just like, oh, randomly sets it here, sets it there, sets it everywhere. And yeah, you get some value, and you end up getting sort of a state of charge that ends up at, like, if you think of the green line, about 25 or 30%. Not great, right? So, but what happens if we play it lots and lots of times? You play it lots and lots and lots of times, and you see this is what we're looking for. It's trips with the state of charge less than 10%. We're trying to get to zero, but we're trying to do is reduce it such that we don't have any trips with less than 10% state of charge, and we're getting at a score where it's actually improving over time. And you can see that, you know, we give it some arbitrary score, and it actually improves the trips. So what's the result? Well, if we take one in-use trip like this one here, which is a stem route, which just goes from a depot to a delivery area and then comes back again, Wilmington, North Carolina. It doesn't matter. So the trajectories of two routes. So you see this, the LSET is being changed. What our algorithm is changing, and it's changing it based on the purple line. The state of charge comes down. And you can see that we did about 15 trips of this in total, and we were able to control the state of charge to get down much lower than it would have with the baseline value. And what we can see in the results is that the average improvement was about 21.8% on all these trips. And we were able to really improve this equivalent miles per gallon just by running this algorithm in real time during the trip and allowing it to change that value to improve the efficiency. The cool thing about this, and just to point this out, is that the driver had no idea, because it doesn't affect how the driver drives. It's not eco driving. It doesn't like shake them or tell them or give them warnings. All it's doing is monitoring the system and trying to figure out what the best way is to use it. And it's completely transparent. The other thing that we did in the project was look at energy efficient routing. And I have one slide on this. Essentially, this was work that was done with Professor Shekhar and his group. And in this work, essentially, we looked at eco routing and we used some new methods. So we're all familiar with how Google Maps works. Well, we don't know the algorithms behind it, but we know that it essentially gives us the fastest path. And in this case, you can see in the results, what we developed was we call a trajectory aware path selection algorithm that used a predicted in an actual, so that we used the Google Maps to give us the fastest time. And then we actually predicted what the energy consumption would be if we used our path aware selection algorithm. And we led to about a 12% energy use reduction with moderate time increase. So the time actually goes up. So one of the things that fleets are going to have to understand is that if you want to have a more efficient route in terms of the vehicle energy use, you may have to take a little bit of hit on time. And that's something that we really haven't done the customer understanding of whether fleets are willing to take a few minutes off or add a few minutes to their trip in order to save some fuel. But 12% energy use reduction is pretty considerable, and it's definitely something that that fleets are starting to look at. And in my remaining couple minutes here, I just want to tell everybody about a couple of new projects that we have going on. We have this intelligent energy management system for Class 8 regional delivery. And this one, we're working directly as a subcontractor to Volvo. And Volvo is going to be bringing 2 electric Class 8 tractors to Minnesota in 2021, hopefully. And we'll be operating them within the Murphy warehouse fleet. So this is a key, this will be a key demonstration, which I hope all of you will hear about as this happens. The idea is we're doing very similar stuff to what we did in what I was just talking about with regards to UPS vehicles, except applying it to Class 8 trucks that are moving freight around the cities. And we'll also be working with HEB in Texas, which is a grocery chain there. We're also going to be doing some energy efficient routing as well, and predictive charging strategy for a given route. So where if the truck needs to charge while it's on the route, where does it do that? So that's going to be an interesting project, and it's one that we've been working on now for some months. This is a brand new project that I mentioned is kicking off, and this is another renewable. This is another project that's funded by the Department of Energy. We're also working with the Renewable Energy Research Laboratory, so the NREL group. Pepsi and Geotab are partners on the project, and the idea is that we're trying to develop a tool, a computer, essentially computer tool that'll allow fleets to understand the applicability of EVs on their routes, more in the Class 8 space. So looking at these large trucks and how Pepsi might be able to deliver and meet their delivery demands using their electric trucks. So they have some grants to actually purchase electric trucks in California. They have a couple of fleets that are already being implemented, and we're going to be using data and telematics data from those fleets in order to develop these models. One of the key things about this is that we'll be developing a novel mass prediction algorithm. So as I said, mass is a huge factor when you're talking about delivery trucks. Pepsi, for instance, delivers both soda, like in water bottles, and chips. So chips are like nothing, and then delivering an entire truckload full of liquid is huge, right? So the difference in payload that they have is really significant, and will have a major impact on whether they can implement EVs on those routes. So, all right, so I've sped up a little bit, so I'm only 1 minute over. I just want to summarize a little bit here and say, medium and heavy duty vehicles have high carbon impact. As I've pointed out, electrification can significantly reduce emissions. And although it's not a cure-all, telematics and connectivity is growing. So certainly telematics connectivity is a growing thing that we're actually looking to expand more and to be used to enable electrification by range prediction and other things that we're doing. And research is using data to lower energy use, improve range confidence for commercial EVs. So as we get closer and closer to electrification, we want to understand how these tools can be used. So with that, I'll end my talk. So thank you for your attention. Doug, you there? Oh, there you are.
Yep, I'm just coming back. Yep, thank you, Will.
Yeah, thanks.
We will then switch over to Siri here, and we'll have we'll get her presentation up and going, hopefully, and then we will have questions and answers after this presentation is finished. And feel free to have questions, to use the Q&A or chat to ask questions as the talks are commencing. There you go, Siri, take it away.
Thanks, Doug. And thanks for having me this morning. I'm really excited to talk to you all about the Pathways to Decarbonizing Transportation project. Like Doug mentioned, this was a project that sparked conversations about the next steps to achieve a low carbon transportation future in Minnesota. So the project did this through stakeholder engagement and modeling that resulted in a set of actions and recommendations that I'll be talking about today. The project was led by Mndot, but it was also supported by a multi-agency steering team. And it was funded by the Minnesota Department of Transportation along with the Environmental Quality Board. So I would like to start out with providing a little bit of background about Mndot and our role as it relates to energy and the environment. Our originating statute identifies a set of transportation goals that Mndot is responsible for. So a couple of those are highlighted here. We are responsible for ensuring that planning and implementation for all modes of transportation is consistent with environmental and energy goals. Specifically, we're also responsible for reducing greenhouse gas emissions from the state transportation sector. And Minnesota established the Next Generation Energy Act goals in 2007, which set greenhouse gas emissions reductions targets for the state. Those were 15% below 2005 levels by 2015, 30% below 2005 levels by 2025, and 80% below 2005 levels by 2050. So the 2015 and 2025 goals are shown by the green line on the slide. And then the blue line is the Minnesota state greenhouse gas emissions. So you can see that the state didn't achieve the 2015 target, and we're not on track to meet the 2025 target. This chart from 2016 shows the breakdown of greenhouse gas emissions in our state by sector. And you can see that transportation became the largest emitter of greenhouse gas emissions in the state in 2016. So the Pathways project aimed to start the conversation about making meaningful progress towards the Next Generation Energy Act goal. I know that this chart is a little bit dated, it's a few years old, but our internal estimates show that the transportation sector in the state continued to be the largest emitter of greenhouse gas emissions through 2019. So like I've mentioned, the project had three key components. The first was technical stakeholder engagement. So this involved bringing together stakeholders to inform the modeling assumptions and the strategies. The second was the modeling itself. So modeling different pathways to get towards a low carbon transportation future. And then the third was public engagement, which looked like meeting with the public to get reactions to the modeling and also gather other insights to inform the actions and the recommendations that were developed as part of the project. So the Pathways project focused on surface transportation, and this slide explains what specifically that included. So it included cars, trucks, buses, RVs, and motorcycles, which account for about 70% of transportation sector emissions in the state. Aviation, maritime, pipeline, and rail emissions were not included in this assessment because in most cases they have a different set of stakeholders and potential solutions. You'll also see mobile air conditioning emissions as something that we included in our research. These come from the chemicals that we use to cool our vehicles, and they're used in refrigerated trucks. These are largely regulated at the federal level, and there are technical solutions that are being phased in. They are also quite expensive. So just to talk a little bit about what our stakeholder engagement looked like, we hosted 3 technical meetings and they included about 100 unique attendees. So these stakeholders came from the public sector, the private sector, the nonprofit sector, and they met to discuss the inputs that went into the model, as well as the metrics that should be used and the constraints that should be used in the model. So they came up with this list of potential actions that we used in our modeling, and they fell into a couple of different categories. The first was driving vehicles that pollute less per mile driven. The second was simply driving less, so especially in urban and more suburban areas where things like transit, biking, walking, and living in more dense communities is possible. The third one was increasing electric vehicle use. And then the fourth one was cleaning up the fuels that we use, both in terms of using cleaner electricity and in terms of using cleaner biofuels. So the model looked at what combination of these things could get us towards the Next Generation Energy Act goals. It didn't necessarily give us specifics on how those things could happen. That is what we got at through the public engagement. So this slide shows a little bit more about how the model worked. It layered in different actions over time. So for example, it assumed that we would start ramping up electric vehicles in 2020. And then by 2030, 40% of light duty sales would be electric vehicles. So we took the results from the model and shared them with different communities around the state to see what they thought about the work that we were doing. So we had in-person meetings in Bemidji, Duluth, Marshall, Minneapolis, and Rochester, and we collected input through online surveys and comments as well. The majority of the respondents were between the ages of 31 and 65, with about 17% of the respondents aged 30 and younger. Most people who participated in the process self-identified as white, with only about 6% identifying as non-white or multiracial. So these are the scenarios that we were looking at in the work. The yellow line shows the reference scenario. So this is the business as usual scenario. This is what would happen with all of our current policies in place and if no new action is taken to drive down greenhouse gas emissions from the transportation sector. Then you'll see the red and the blue line. And these are the 2 scenarios that we modeled where action is taken to reduce greenhouse gas emissions. So the 80 by 50 scenario would achieve the Next Generation Energy Act target for the transportation sector. And then there's also a 0 carbon scenario, that's the blue line. And this goes beyond the Next Generation Energy Act targets. We did this for 2 reasons. The first was that it may be easier to achieve the greenhouse gas emissions reduction in the transportation sector than other sectors in Minnesota. And so we wanted to see what could be possible from the transportation sector to sort of cover for other sectors in the state if we wanted to achieve the Next Generation Energy Act goal as a full state across all sectors. The other reason why we explored this was that there are studies that show it may take more than the Next Generation Energy Act goals to achieve the greenhouse gas emissions that we need to sort of continue with life as usual. And so we thought it would be interesting to model that as well. Again, I want to point out that the modeling that we did showed one way that we could achieve these scenarios, but it's certainly not the only way that we could get to these results. So this is the 80 by 50 scenario. And each of these sort of wedges is a reduction that we could achieve from a certain area of the transportation sector. So the pink is the reduction from the fuel economy standards. The red is the reduction from reducing urban miles traveled. The blues are reductions from electrifying vehicles. The greens are reductions from biofuels, and then that beige wedge would be the reduction from mobile refrigerants. So like I said, the modeling didn't really provide us with policies or incentives or specific programs. It was a bit more high level than that. So we took what we got from the modeling and our public engagement, as well as advice that we got from some of our external partners like the Great Plains Institute, the McKnight Foundation, and Energy and Environmental Economics, which was the consultant that did the modeling. And we created a set of actions and recommendations that were included in the report. So the actions are things that Mndot can carry out, and the recommendations are things that the state could carry out, but that our agency doesn't have direct control over. So I'll walk through those actions and recommendations. So we heard through our outreach that it's important to find integrated solutions to these challenges, and it's also important to provide more electric vehicle infrastructure. So one of the first things that Mndot explored was creating a new council to advise the state on how to achieve this goal. And I will talk a little bit more about that in a few slides because it's one of the areas where we've had a lot of action in the last couple of months. We also committed to coordinate with other state agencies in Minnesota and throughout the upper Midwest on promoting a shared electric vehicle experience and making it easier to travel around the Midwest by electric vehicle, which builds off of the work that was done to establish I-94 as the first signed electric vehicle charging corridor in the US. And then finally, at least for this slide, we established a 3-year pilot program to demonstrate the potential for innovative clean transportation technologies to reduce greenhouse gas emissions. And I will talk about that in a little bit as well. So a few other things that we heard in the outreach were just about the importance of having more transportation options on projects, and also about how valuable it can be to have an electric vehicle incentive for spurring that and advancing that adoption of electric vehicles in the state. So Mndot began analyzing greenhouse gas emissions for our project construction and operations, meaning traffic emissions, as part of the Minnesota Environmental Policy Act documentation for our transportation projects starting in January of 2020. And we're planning to use these results to inform project planning and design so that we can find ways to reduce greenhouse gas emissions in the future. We also launched another pilot project to help increase the number of electric vehicles in Minnesota and also create new MinPass users. So we established an incentive that is for the purchase or lease of a new or used electric vehicle anytime between November 2019 and October of 2022. So this is a one-time toll credit that goes into the customer's account to pay for toll charges when they're using MinPass. So shifting into the recommendations, and again, these are things that Mndot doesn't have direct control over, but were still identified as important pieces of this work that our partner agencies can carry out. So when it comes to building the electric vehicle market, we heard from our technical stakeholders and the public, and also from representatives of very large employers in the state, that there's a need for more electric vehicle options in the marketplace. And that lack of options is a real barrier to electric vehicle adoption. There also was just a general dismay about the potential weakening of the federal fuel economy standards. And so for those reasons, we added an item in here about the clean car standards, and Governor Walz directed the MPCA to begin rulemaking to adopt low emission and zero emission standards in September of 2019. And that work is still ongoing. We also heard a bit about biofuels in this outreach. Many participants wanted to make sure that they played a role in Minnesota's low carbon transportation future. And there was additional support for them when there were conversations about how they could support farmers, specifically how biofuel could support farmers using practices that support water quality. So all of the recommendations related to biofuel are being taken on by the Governor's Council on Biofuels. So it's been a few months since we released the report, and I just want to shift to talking about where we've gone since we started the conversation. One place where we're continuing the conversation is through Mndot Sustainable Transportation Advisory Council. So the STAC is responsible for helping Minnesota transition to a low carbon transportation system and doing so in a way that considers other things like equity and safety and reducing inequality. So the council is chaired by Commissioner Margaret Anderson Kelleher and also Xcel Energy CEO Chris Clark, and it includes 23 members of the public, private, and nonprofit community, as well as elected officials. So the council is carrying out its work by creating these 4 work groups that are focused on fueling and powering transportation, reducing VMT, supporting resilience, and thinking about transportation funding. And the work groups are developing draft recommendations to Mndot on how the state can reduce greenhouse gas emissions from the transportation sector. So those are due at the end of the calendar year. And then finally, I want to touch on our clean transportation pilot program. This, like I mentioned, is focused on demonstrating the potential for innovative clean transportation solutions. Excuse me. And we're really excited about how this program can support this work in Minnesota, especially in greater Minnesota and in communities that maybe haven't had access to it before. So Mndot is distributing up to $2 million annually in grants that will range from $25,000 to $500,000. The letter of interest period starts on November 2nd and will run through December 7th. So more information about this is available on our website. And with that, I will wrap up my time and see if anybody has questions for me or for Will.
Thank you so much, Siri and Will, both of you guys. A lot of really good information. So as a reminder, please submit your questions in the Q&A. If you would like to ask your question live, let us know and we can unmute you. I think we do have some questions to start with. And let's see, our first one here, I think, is for Siri, which is more and more states in the US, including Midwestern states like Illinois and Wisconsin, are realizing that a key part of a successful carbon reduction plan for the transportation sector is the improvement of passenger rail service between medium and major cities, along with well-coordinated intercity bus service. Passenger train and bus networks are a proven way to reduce the transportation carbon footprint because they reduce reliance on carbon-intensive private autos and aviation. A train and bus network is also a proven way to carry package and mail traffic. What is Minnesota doing in this regard?
Yeah, this is a great question. So the Pathways report didn't cover rail, but I can say a couple of things about what Mndot is doing to support both rail and intercity bus. So on the rail side, Mndot developed a statewide freight and passenger rail plan that has goals for how we're going to advance intercity passenger rail. And there are 2 projects that we're working on. One is the Northern Lights Express, and the other is the Twin Cities Milwaukee to Chicago project. So these are in the advanced planning stage, and we're just waiting for funding from the state legislature to move those forward. On the bus side, Mndot has been involved in supporting intercity bus for a while, and We do this through grant contracts with Jefferson Lines. And so there's more information on our website about the network that was developed in the state. There's a good map that sort of shows where the routes are. Oh, Katie, it looks like you're on mute.
Thank you. It looks like I have another question for Siri here. At least I think this is for you. Does your reference scenario assume no change in EV usage 2015 to 2050?
That's a good question. I think it assumes some small increase in EV sales. I don't remember the exact number at this time, but the Pathways report is listed on the Mndot Sustainability and Public Health website, and all of the detailed assumptions are included in the appendix. So I would recommend going back to the report to look at the appendix to make sure that you can find the specific assumptions for the reference scenario.
Okay, great. Looks like I also have a question for Will here. Do the algorithms or knowledge from these projects become public or open source for everyone to build on or proprietary? I think that's one for you, right?
Yeah, no, that's fair. Yeah, so the algorithms we developed are published in the literature. So if you want to see some of the work that we've done, you can, if you want to work through that, you can. I've provided a couple references in the slides that will be presented, that will be provided to you after the meeting today. And in terms of the proprietary nature of it, we definitely have some intellectual property that's being developed as part of the projects that we're doing. But most of this stuff, after it's been sent through the Office of Technology Commercialization, gets published. So I would say 90% public. So.
Okay, great. All right, Siri, another question for you on your mention of grants. Where can our participants get more information about the grant program?
Yeah, so that's on the Mndot Sustainability and Public Health website, and I will drop a link in the chat right now.
Great, thank you. All right, as a reminder, please continue to submit your questions in the Q&A. And I think, let's see here, I had a question for Will about the drivers. And it sounds like as you're trying to automate as much of it as possible so drivers don't even notice. But what work have you done with drivers? Is there resistance or support from a lot of the drivers? And what kinds of complaints do they have? Is there anything that they notice about their ability to get their jobs done?
Yeah, in terms of that, our goal is really to aid drivers and not to control things that take away from safety or from their ability to do their job. So we haven't really had any feedback from drivers. In fact, we're trying to just avoid it entirely. I mean, in terms of the interaction, you know what I'm saying? Like we don't want to have any negative impact on safety or performance of the vehicle. In fact, that's sort of kind of part of the appeal of what we're doing, is we're trying not to impact, even though driver behavior plays a huge role, we're trying to adapt around driver behavior, understanding that people drive how they drive, and it's up to fleets to sort of manage their own personnel. So we're trying to avoid the human factor and more focus on the vehicle itself. Yeah, it's a good question though.
Very engineer approach, I think, but
it's appropriate, I guess.
So Siri, maybe kind of along the same lines, or maybe either of you could answer this. Do we know how many electric vehicles are out on the roads now? And it sounds like maybe personal vehicles are the largest component of carbon users. So what percentage do we have? What percentage do we need? And what is the rate of adoption?
Yeah, so I can say in terms of registrations, Mndot has a great dashboard on our website. I can post a link to that as well. The last time I checked, it was about 12,000 registrations in the state. So we're still sitting under 1% of total registrations, which is pretty low. I think to get to the goals that we set in our report, we would need to see substantially higher rates of adoption. I'm just going back to my slide to double check that I get this right. So we would want to see 80% of light duty sales be electric vehicles by 2050.
I can just say that from a vehicle technology perspective, right now you're seeing rapid advancement in the technology that's coming out of automakers, and I feel like cost is a key consideration when people are deciding on what to purchase. And I know there's incentives and stuff that Siri was talking about, but still, there are a lot of anxiety about how much these vehicles cost. And of course the range considerations as well. So, as I said, if I work both in the engine world and in the electric vehicle world, and I can see the engine, in the engine world, the improvement's very incremental. In the EV world, there's just rapid transformation happening all the time with solid state batteries, with wireless charging, with with power electronics and motors, and the costs are coming down considerably. I don't know what the limit is necessarily, but I know that as costs come down, maybe we'll reach that 2050 mark. I hope. I mean, I don't know. It seems kind of crazy, but maybe we'll reach it.
Very cool. All right, another question here. We have the prospects for reducing greenhouse gas emissions from biofuels are heavily dependent upon the type of fuel source used. Did the modeling conducted by consultants account for this aspect of a biofuels promotion policy?
Yes, so it made some assumptions about the type of biofuels that would be used, specifically that we'd be using higher level blends of biofuels like a B100 by 2050, and that the fuels that we would be using would have some of those more positive impacts on water quality. So maybe like not your grandfather's biofuels type of scenario. But this was I would say this was definitely a topic of debate as we were doing our stakeholder engagement. It was one of the areas where we really didn't have agreement among stakeholders, maybe in some of the ways that we did on electrification in general. We had a really strong support for biofuels, and then we did have some stakeholders who had concerns, especially based on the historical impacts of biofuels.
Okay. Another question here, where does VMT reduction fit in? Isn't that the cheapest option with the quickest possible implementation? Also, how about innovations in the parking space? Going to daily parking rates in urban centers would have a significant impact on the choices people make.
Katie, I'm guessing that one's for the pathways content as well.
I'm leaving that for you, Siri. I don't know. I just see it, VMT goes down, but
yeah.
I don't know.
Yep. So for the pathways report, VMT, I think, was maybe a smaller wedge than some people would have liked at the end of the project. And part of that was driven by the assumptions about VMT reductions in outside of urban areas. So we did not necessarily model VMT reductions outside of urban areas. But I will add that it's something that Mndot thinks is really important for moving forward towards this low carbon transportation future. It's also really critical when we think about equity and safety in our state and the type of users that don't have access to cars. So for that reason, the stack created a VMT reduction work group, and that work group is responsible for developing recommendations to Mndot on what we can be doing to support VMT reduction.
Great. How about any idea of the power source of the state's EV fleet? Are they all plugins or hybrids included? And any idea about hydrogen power source to drive the EV vehicle? I'm not sure what that last part was, but I think that one's for Siri.
Yeah, well, in terms of I can talk a little bit about hydrogen, but I don't, but in terms of the power distribution, I think that's pretty well. Is that documented with Mndot as well? The power distribution sources?
So I don't know how well documented it is within our report. We used EIA sources and the MPCA for our assumptions about the electricity grid that the EVs would be using. I think the PCA has some good data on that. In general, I would say that the power source really varies depending on where the EVs are being charged. So the power mix in Excel territory is slightly different than what it might be in a utility in greater Minnesota.
Yeah, I mean, I know Xcel Energy, I'm sorry, Siri, I know Xcel Energy has a renewable plan, right? They have a carbon-free plan where they're going to they would like to go to 100% carbon-free by 2050. So, yep. I mean, going along with the 50% sales of EV in 2050, I think that certainly changes the mix over time, right? So I think it's not a stationary thing.
Yep, exactly. And then Katie, was there a second part of that question about plugging in?
Let's see, there was. Let's see, any idea about the power source of the state's EV fleet? Are they all plug-ins or hybrids included?
Oh, so this is maybe, I guess I can't tell in this question whether it's the EV fleet in Minnesota or the state-owned electric vehicle fleet. If it is a question about the state-owned electric vehicle fleet, there are a number of fully electric vehicles and plug-in hybrid electric vehicles, and the state is working to bring in more. So I don't know if the person who asked that question has any follow-up based on which state fleet the question was about.
I think that was the correct state fleet that you answered. It was about the state's vehicles that they operate. Okay, another question we just got in here. Since densification of the population recommendation, that message reaching the ears of city planners to move away from single family home zoning only to more multifamily homes. I guess I guess maybe Siri, is that included in any of the state's work to reduce carbon emissions around transportation?
Are we working with city planners to increase density?
Basically, yeah, to move away from single family home zoning.
Yeah, that's a really good question. I'm not aware of work. So our office isn't necessarily doing work on that. I think there may be work in the Mndot districts who work more on a project level to collaborate with cities to plan projects that sort of get at those goals. I certainly think it's an active area of conversation in the agency, that connection between land use and transportation. And I don't think we've quite figured out yet what our role is in terms of advancing more dense communities. But overall, I think that the Pathways report showed that it does play a role in the low carbon transportation future that we would like to see.
Okay, great. I want to thank you both again. We're kind of at that point where we're going to transition to our round robin. So if you would like to share something, please enter something into the Q&A and we can either call on you or just read that to you. And I guess maybe we can also use the chat. I think that you guys are, I don't know if you're able to enter into the chat, but either place, if you would like to share some of the work that you're doing, let us know. We can either call on you or I can read it out loud.
Katie, this is Gina. It might be interesting to hear from Amanda kind of what the latest is with the MPCA work. So we could unmute Amanda and maybe she could share what's going on. So Katie Kirk, do you want to maybe unmute Amanda?
Sure, I can do that. All right, Amanda, I think we have you on unmute if you are there.
Okay, I'm here.
Great.
I would have turned on my camera, but I also don't know how to do that on this platform. So yeah, we are still working on the Clean Cars Minnesota rulemaking. We've had a variety of timeline changes in this crazy year that we're having for a variety of reasons, partly because of the pandemic, partly because of federal regulatory actions that they've been taking, and partly just us kind of wanting to make sure that the analysis is done well and done right. So we are still on track to publish our draft rule and our cost benefit analysis, which is housed within the statement of need and reasonableness this fall, although I would say that the snow on the ground outside my window here is making me question what fall is and what winter is, but coming up here. So I would encourage folks, and I realized that I was trying to post links or a link at some point during and I just shared it with the panelists by accident, but I can post in the chat a link to our website where you can sign up to get emails, and then you'll know when we actually publish the rules and the analysis. From there, once we publish that, there will be another comment period. We'll do some public information sessions where we share information about the rule and the analysis that we did. And then there will be hearings in front of an administrative law judge who will ultimately decide whether or not we are able to adopt the rules. So I'd be happy to answer questions about that. I also wanted to share, and I was trying to share this before, there was some questions about EV data, and the PCA and Mndot have an electric vehicle data dashboard. I chatted the link to the version on our webpage. There's an identical version on Mndot's webpage. So if you are interested in exploring EV adoption information in Minnesota, that's some good data that's up to date. And then another item I'd like to share is that we are working on our biennial greenhouse gas inventory report. So the data that Siri was sharing about the emissions in Minnesota of greenhouse gases and the different sectors, that's from a report that we put out every 2 years. And so the next report will be coming out in January 2021. So we're excited to get that information out into the world as well. And then I think a final thing I'll share is that I think perhaps you are probably all aware that towards the end of 2019, the governor signed an executive order establishing a climate subcabinet and a climate advisory committee. We've been working on an interagency basis to kind of establish the various bureaucratic structures that we need to actually implement that executive order. And there are several action teams, one of which is led by Mndot and is on transportation. There's several others related to other sectors of the economy. And so that is kind of work that I keep hearing people describe that we are flying the plane while we build it or building the plane while we fly it. But so it's kind of an iterative process where we're figuring out how to do this work interagency as we're setting it up. But that is some exciting stuff that we're starting to get moving at the state. So I'd be happy to answer any questions about that. Otherwise, thanks for the interesting presentations today.
Thank you, Amanda. If you have any questions for Amanda, please put it in the Q&A and we can get those to her. She also provided a link in the chat if you want to check out any of the information she was talking about. We at the Energy and Environment Council are always interested in finding out what you are working on in your industry and what your organizations are facing. So feel free to share those with us either now in the chat or the Q&A or sending emails to the council. Like I said, we want to make sure that we're providing current information on what you're all interested in. If anybody has anything that they'd like to share about the work that they're doing, or if you have any updates about your organization or other events, we'd also be really interested in hearing about any of that.
Katie, I think Sheila Hatchell from the Mndot Library had an update.
Oh, great. Yes. Let me see here. All right, so also in the chat, Sheila sent a link. She wanted to share that the Mndot library produces a weekly current awareness alert on the topic of sustainability, public health, and transportation. If you'd like to receive that, the link is in the chat.
It also looks like Libby Ogard has her hand raised. So I'll
Katie, could you?
I unmuted her. So
Okay.
if you have or you can unmute yourself, I guess. Libby, if you're trying to talk, we aren't able to hear you.
Okay, maybe this works.
Yeah.
Is there any thought or effort around mode conversion from truck to rail, or from truck to intermodal? Is that part of your scope, or does that fall outside?
Is that a question for Siri or Will, Libby, in particular?
It would be a toss-up question.
Okay.
Yeah, I can say in the pathways report, that was not part of our scope.
Okay.
So I guess what I'd like to mention is that if you look at the sustainability factor of inland waterways and using the marine highway, that has huge environmental benefits, as well as the fact that Minnesota has access to Port of Duluth and the inland waterway in the Mississippi. I'd like to say, I think it's worth thinking about expanding mechanisms by which to leverage not only the rail network, but the inland waterway network kind of beyond trucks. So that would just be my 2 cents.
Yeah, thanks for that, Libby. We have also been doing some engagement through the Governor's Climate Change Sub-Cabinet work that Amanda Smith mentioned. And we've heard similar sentiments. So it's really helpful to hear them echoed here. And I'm not quite sure yet how we'll be exploring that, but I think it is something that has come up in conversations since the Pathways report. So thanks for bringing it up here too.
Thank you.
All right, I don't see anything else in the Q&A or the chat. So with that, I guess Gina or Katie, are there any other announcements before we sign off?
Nothing from me other than to say we hope to see folks at next week's CTS Research Conference.
Great, thank you. And thank you again, Siri and Will, for the great information and the presentations. With that, I hope you all have a great week.
Thank you.